So chapter 20. More on tests and intervals. It kind of puts together what we learned about confidence intervals and what we learned about hypothesis and put them together. But first, let's look at some vocabulary words. The alpha level, or significance level, is the threshold p-value that determines when we reject a null hypothesis. If we observe a statistics whose p-value based on the null hypothesis is less than that alpha, usually 0.05, we reject the null. So before we've just been talking about it, now it actually has a term. It's called the alpha level or the significance level. Now note, it is usually 0.05, but not always. It doesn't have to be this value. You can set it to whatever you think seems right. It could be 0.01. That occurs sometimes. Statistically significant is when the p-value falls below the alpha level. We say that the test is statistically significant at the alpha level. So when you are below, let's say that usual 0.05, then that's when we reject the null, and we call that statistically significant. Another word is power. The probability that a hypothesis test will correctly reject a false null hypothesis is the power of the test. To find power, we must specify a particular alternative parameter value as the true value. For any specific value in the alternative, the power is 1 minus beta. We'll see more about that later. Let's go back and refresh on how to interpret the p-value. So, the question of whether the diabetes drug Avidia increased the risk of heart attack was raised by a study in the New England Journal of Medicine. This study estimated the 7-year risk of heart attack to be 28.9% and reported a p-value of 0.03. For a test of whether the risk was higher than the baseline 7-year risk of 20.2%. An earlier study had estimated the 7-year to be 26.9% and reported a p-value of 0.27. So let's focus on the 0.27. What does that mean? As a reminder, think of that as a percentage. What percentage of the time will our, let's say, 26.9% be higher than the baseline? Well, it says here about 27% of the time, 26.9 will be higher than, or my value would be higher than my baseline, which is a pretty big value, right? If I were to take this test, notice one of our tests ran it and it got 28.9%. If I were to run it 100 times, I would get higher than 20.2 27 times, which is a pretty big number, right? This is why we would not reject, we would not reject the null, that it is higher, because we're seeing it quite often. That is definitely above our normally suggested alpha level, 0.05. So a p-value of 0.27 means that a heart attack rate at least as high as the one they observed could be expected 20% of these similar experiments, even if in fact there is no increased risk from taking Avidia. So even if there isn't, it's still coming up 20% of the time when we're running experiments. That's what our p-value represents. So how often, or what's the likelihood of us getting our null hypothesis? Let's look at confidence interval and how we can use that to determine, do we reject or not reject the null. In a recent poll of 1,000 randomly selected adults, a president's approval rating stood at 49%. Make a 90% confidence interval for his approval rating by all adults in the county. And then based on the confidence interval, test the null hypothesis that 49% of the county approved of the way he was handling his job at the time. So, it's been a while. Let's look at how to find the confidence interval. Like almost everything in this class, we can look at the calculator. Confidence intervals, we're right here at stats, test, one proportion z interval. One proportion z interval. Click on that. It's waiting for some values, x, n, and your C level. X is 490. Now where did I get 490 from this problem? How did I come up with an x value of 490?
0.49 times 1,000.
Yeah, take my n value, right, which is 1,000, and multiply it by 0.49. That gives you 490. Your x. And then my n is the number of participants, 1,000. And my level, what confidence interval I'm going to test at? 90%, so I'm going to do 0.9. So I get my confidence interval of 0.464. That's my low end, and my high end as 0.516. Now to use your confidence interval, take your hypothesis. So what would be my null value? P what? Equals,
0.49.
thank you, 0.49. And is that value in between my confidence interval?
Yes.
Yes. So if it is, then that means I cannot reject the null. So like so. So I failed to reject it because it fits within my confidence interval. So we're just stuck at that. Run more tests. So that's how you can use confidence intervals to accept or reject your null. Not just have to do that one proportion z test. You can do a one proportion interval test. Another way of looking at it. Now there's some other things about accepting and rejecting the null hypothesis, and that is called the type 1 error and type 2 error. You've heard of these before, but not in this terminology. A type 1 error, the error of rejecting a null hypothesis when in fact it is true, also called a false positive. I'm sure you've heard of that before, somewhere. The probability of a type 1 error is alpha. So if you set your alpha level, which is the usual, at 0.05, then that pretty much means you have a 5% chance of rejecting the null, but it actually ends up being true. Which is still kind of small, right? 5% chance. A type 2 error, the error of failing to reject the null hypothesis when in fact it is false, also called a false negative. The probability of a type 2 error is commonly denoted by beta and depends on the effect size. So type 1, we reject the null hypothesis, but it ended up being true. Type 2, we failed to reject and it ended up being false. So let's look at some examples. Is this a type 1 or a type 2 error? A bank wants to know if the enrollment on their website is above 40% based on a small amount of customers. They test, so their H null is P equals 0.4 versus their alternative, HA, P is greater than 0.4, above the 40%. And they reject the null. Later they find out that actually 38% of all customers are enrolled. So they rejected it. They say that since they rejected this, they're saying the alternative is that the value is greater than 40%. What type of error do they make? A type 1 or a type 2? Remember, a type 1 is they rejected the null when it is true. Type 2, they failed to reject a null that is false. So which one happened here?
False positive.
What's that?
Type 1.
Type 1, right?
Yeah.
The bank made a type 1 error. The actual value is not greater than 0.4, but they rejected the null hypothesis. Type 1. Notice the key word here is usually with type 1, you do what?
Reject.
You reject. ended up being wrong. So think of it like that. Type 1, relationship. You got rejected, but she still liked you.
Nice.
But we can still be friends, right? All right, give me one. A human resource analyst wants to know if the applicants this year score, on average, higher on their placement exams than 72.5 points the candidates averaged last year. So they want to know, is it higher than what they scored last year? She samples 50 recent tests and finds the average to be 84.1 points. She fails to reject the null hypothesis that the mean is 72.5. At the end of the year, they find that the candidates this year had a mean of 85.3. What type of error is this? So they had their H null, P equals, actually knows probability here, so we'll just say that they assume that the mean is going to be 72.5. And HA, supposed to be an A, is they think it's higher. So they fail to reject but the average ended up being higher. What type of error is this?
Type 2.
Second one.
Second one, right? Type 2. So an analyst made a type 2 error. The actual value was 85.3 points, which is greater than the 72.5. So yeah, type 2 is when you fail to reject. So you actually end up dating the guy, and he ends up being the a-hole. Type 2.
Nice.
If I can go with that analogy. Okay, one more time. Type 1, you start off, you'll see the word rejecting. They rejected it, and they were wrong. Type 1. 2, they failed to reject, and they were wrong. Type 2. Try to get those kind of memorized.